Righty, we are close to break. Yeah, you got a question? Well, this one was kind of a question for us because it's about the project. Yeah, we can talk more about that. Well, the one freaking routers themselves are each router a different parameter was. So you'll have some number of rotors, like three rotors, right? Rotor one, rotor, whichever of the five that they're picking here. And I found they do have the nice picture of it here too, which is cool. So this hopefully illustrates it a little bit better here. So it's the parameter rotors for rotor one, rotor two, rotor three. So you need to tell it which rotor for which position out of your five rotors. Yep, and then those become the spinning rotors one, two, and three here. Step five of this process here. Right. So step one of the process, right? You press a key here, and then step two, it goes through and may or may not hit one of the plugboard pairs. Right, the plugboard pairs, you get 10 pairs here. Right, could be more, could be less, but usually they did 10 pairs. Really, it's configurable any way you wanted to do it here. Swapped it to a different one, and then it goes through the plugboard, then into the sets of rotors. Okay, so the in path, it starts hitting the first rotor, right, and that maps to another character. And the second rotor maps to another character. The third rotor maps to another character. Then it hits the reflector. The reflector doesn't spin. This is like a fixed position one. So it's easiest if you just see this one at 0. That'll make your life easy, and then everyone's will match. So if you just seed up that's essentially a bunch of pairs here going on. This one maps to this one. This one maps to this one. This one maps to this one here. As we go, you do it that way, and then it comes back through the rotors again with a different letter. So you could hit a different mapping going from this side to this side, this side to this side, this side to this side. And every time you press a key, one of the rotors spins, the one on the right. So depending on what position you're on, right, you start, hey, I want to start at position 5, it's going to spin to position 6, spin to position 7, position 8, position 9. Once it wraps around, it kicks over the middle rotor here. So somewhere between 0 and 26 letters, the middle one's going to rotate. It's very unlikely your message will trip the third rotor, right? Because that's 26 times 26. But this one could have been in the position where, the first time it rotated, it also rotated the third one here. So it's the positions that they're in are going to matter. Yeah. Okay, so like, what if when we're doing the ran int, we hit the same number twice? Well, so you need to set up each one of these rotors so that it has a mapping, and then when it spins, the mapping changes. And when it spins, the mapping changes. After 26 spins, you're back to your original mapping. No, I mean, like, what if, like, say, 26 that's like when you're doing the random game thing, you get like you get like 1, 2, 3, 4, 5, and just to get 1 and 10 for example. I'm not following, sorry. With random numbers? Like, are these numbers going to assign to one of the letters? Yeah, so you use the random number generator to, inside the rotors, set up your initial mapping. And every time it spins, you can just increase it by 1. So we just need to generate your mappings, and then every time it spins, you just shift it by 1, and shift it by 1, and shift it by 1. So if it did map to an E, maybe now it maps to an F. No, I mean, when you're generating them, I mean, because the random can potentially do the same number twice or more. So ignore it then, or make sure you don't get the same number twice. Right, we got lots of options when we generate random numbers. So my problem with that was when after you hit that one of your letters, when you do it might not have a mapping. So make sure it does. All right, so hopefully the picture helps make sense here. So essentially, your reflector's a rotor that doesn't spin. If that helps at all, that's a nice, easy way to go about it here. So we're gonna have a couple different classes here. I didn't put it in the rubric here. Sorry. So the rotor itself needs to know which rotor numbers and which position they're in. So out of the 5 rotors, or really it could be infinite at this point here, but assume it's the 5. You say, hey, I want rotor 4, and I want rotor 2, and then I want rotor 3. Right? And they'll go in that order. And then what position do each of them start in? Okay, so this one starts at position 3. I'm 3 clicks in. This one starts at position 25. This one starts at position 7. Right? Whatever it happens to be here. So you set up the initial rotors and the starting positions. Then you set up your plug board, right, which is just 10 pairs of letters. Really, it could be any number of pairs, but if you want to do 10 pairs, that's the usual standard starting here, right? So the 3 rotors, 3 positions, and then the 10 pairs for your plug board. That sets it up here. And then any message you give it, we can encrypt. And if you put it back into this position here, any message you give it that's encrypted should decrypt here, right? You just start back at this given position, and instead of giving it the plain text message, you give it your encrypted message, and the mappings should go in reverse, right? Because it's just everything maps to another letter, everything maps to another letter, maps to another letter. So whatever you put in comes out. That should map the same direction. Putting in the encrypted letter comes out to the plain text letter, right? Because it just follows that sequence of pairs. So you want to make sure your letters are always paired. So for anything in, you get this out. The same out gives you the same in, right? Yeah.
So the pair is going to be random every time we run it. The starting position is always set there.
You set the starting position, so this many spins, right, essentially of each rotor here. And then if you use the rotor number as the seed value, then you'll always get the same seed sequence every time you start, because you don't want it to be a new set of random sequences. You want it to be the same set of random pairs every time, right? Because that way it's repeatable. Right, and we looked at, you can do that with the seed function here, right? So if you import random, say random.seed. So if you just say, hey, like 5 for rotor number 5 here, then you'll get the same number in range. Well, let's do 10. Random.randint. We'll just go up to 10 numbers. So I'm going to get the exact same sequence every time. 1 to 10. Goodness gracious. Right. 10, 5, 6, 9. 10, 5, 6, 9. 10, 5, right? Because I've got the same seed here. It's a pseudo random. It's not actually random. This is not cryptographically secure, which is helpful if we want the same sequence every time, right? So just seed it with that rotor number will work out well for you here. And then if you're doing that, hey, I could have rotor 325 here, make this even harder for people to decrypt, right? And the unit tests, right? So we talked about classes. We do unit testing yet? We were going to get to that today, right? Okay, cool. So we'll get into that. I guess I should, want week 8 then. Can we go back? 7. Where'd it go? This is the worst browser. This one makes me sad. 298. Did I lose it? 298. Week 7 objects. All right. So, we did a little bit of testing our speed roll, right? We did some tests. See, I can't remember last week here. That was probably Tuesday. Was it Thursday we did the database presentation? Okay. All right, and the project. That's what it was here. All right. So we're writing tests. So the tests are helpful to make sure that what we expect to get out, we actually get out here. So when we test these things, is it going to work for us here? So when you set up a plug board and it maps A to B, if you give it an A, you get a B. If you give it a B, you get an A, right? It successfully pairs these things here, right? Right. So really all we have is 13 pairs, because then when you shift one side of the pairing to another letter, you still have 13 pairs. Right? You got options, right? Or if you want to shift both of them, right? We can work some ways here. We'll figure that out as you rotate them here. We'll make sure that works. The reflector works basically the same way. We just don't spin it here. You got our rotor. You can give it a given starting position. You'll get out the expected mappings as you go. So encrypting and decrypting messages based on some given settings here. All right. So let me put in rubric here so we know it here. So this is 3. is oriented design. So using classes, you get points just for having classes, right? And I know there's a solution out here. You just search Python Enigma machine. Like we've got one here. Look at this. Here's the Enigma machine. Look, there's a whole bunch of ones here. Wow. 64 matching ones here. Isn't that fun? You can even install it with poetry. That's fun here. Hey, which rotors you're using, what plugs you want to use. There's lots of things out here, right? You give it an encrypted message, you give it a regular message, you give it the encrypted message, and it flips back and forth given the same settings. Yeah.
Is the plug word what pairs and those?
Yeah. Yep. Yeah. So it just says, hey, A maps to V, V maps to A. Just gives it one more set of scrambling that the machine can do here. So there's solutions out here. I'm aware of that. The idea is we're going through the exercise and doing it ourselves and not. I think some of these are pretty bad here. Oh, here's a nice little pretty picture too. Look at that. Right. It's got some stuff here. Right. The goal is not. This is not beautiful code here. This is all based in functions, and this is not as pretty, and it's much harder to test when we go about stuff like this. Right. It's not good design here, but you look at kind of how it works, right? That idea, right? Okay, it's got some coded paths for rotors, plug boards, however it wants to go here, right? Lots of ideas you can take if you need some inspiration. But if you're copy pasting code, cite your source. If you're paraphrasing, cite your source. English paper rules apply, right? Okay, but we're going to do it this specific format here. So object oriented design, we got our classes here. We've got can set up initial settings, 3 rotors, 3 positions, 10 plug board pairs. Then unit tests. So 10 points for checking your own work here with our unit tests. Now, having classes, be able to do your initial settings, and then did you test it here? And remember, unit tests need just one small piece at a time. Right? We can test one individual piece at a time because we're kind of composing these things. Right? And please, everybody knows what inheritance is, but an Enigma machine is not a rotor. Right? There's no inheritance happening here with that. Right? It has rotors, not is a rotor. Right? Most of the time in 200, when I teach that class and we introduce inheritance, people think that is the nail and that's the hammer that they have, and they're going to hit everything with inheritance. And it just doesn't work like that. Okay, it has these things. So the Enigma machine has 3 rotors with positions. It has the plug board with its 10 pairs, right? And it just uses that. Takes the letter, pushes it through the plug board, pushes it through the rotors, pushes it through the reflector, pushes it back through the rotors, pushes it back through the plug board, right? It's that big sequence of sending it through, using all of its connections here. Get me your mapped letter, get me your mapped letter, get me your mapped letter, give me your mapped letter, give me your mapped letter, and eventually rotates these things here. But we can test the small pieces on all the way up through the Enigma machine being unit tested as well, right? You don't like need a whole lot of crazy things here. So being able to encrypt and decrypt, sure, pops up, lets me answer some prompts. Unit testing is going to be easier, but we'll have both in here. Okay. Hopefully not too terrible of an assignment, I promise, right? It sounds a lot, but once you dig into it conceptually, these go relatively quick with your pairs. Yeah.
Can you just separate the settings things out so that I remember which parts are actually not right? The first 3 numbers on your
Yep.
kind of start position.
Yes. Yep. And ideally, because there's more, this is higher than 5, you know that those are starting positions. Because initially there are only the 3 rotors here, right? And then your 10 pairs of whatever, right? You can randomize this any way you want here, right? Or go through your code sheet with water soluble ink is really fun. I think they had a picture of their code sheet, didn't they, in here? Yeah, one of these. This is their monthly settings here. Right. So for a given day, this is what they'd use. This is their positions. Here's their pairs. Right. So you'd have this once a month. They generate these things and send them out to people, and everyone could encrypt and decrypt messages.
I kind of find mine flat in words like that. You just like input one what is on the line from a sheet like this,
Yeah, like here's one line, right?
and it'll just pause it to figure out which one of these rotors, which one of the settings.
Yeah. First three are your rotors, next three are your settings, and then next is your pegboard settings. Yeah, definitely. That works out nice. If you like multiple prompts, you can have multiple prompts. Doesn't really matter, right? It's just however you want to get that information. Should be easy.
thought I thought the user was supposed to pick segments.
Yeah, this is just an example of what a setting input could look like here. Yeah, so ask them, pick the Enigma settings. Yep, and then you get to encrypt or decrypt your message. All right, you okay with that so far then? And if you got questions, that's okay. This one's due Thursday after we get back from break. Is that right? Because we were off the first week. And that's the 13th. Yeah, Thursday after we get back from break. Okay, so we got some time. If you want to not worry about it at all over break, go for it. Don't worry about it all over break. If you want to get it done early, go for it. Get it done early. Whatever you want to do there, up to you. We get back from break. We've got data visualization, our last chapter out of the PY for ebook. Then we'll do a week for midterm review, any other catch up we have to do, and the midterm itself on 319. It's open book, open notes, open internet, because no one's ever going to pay their developers and say, don't look your stuff up, because that's just stupid, right? If you can know where to find the information and how to use it, that's what we're learning here, how we can solve problems. We're just expanding our toolkit. Hey, here's cool things you can do in Python. Now you've got a bigger toolkit for solving problems here. That'll be due by the 24th to start a class. So open it, read it, come back to it, sleep on it, whatever. That's okay, right? It shouldn't take you more than an hour and 15. The goal is I could sit and watch you take it, but that's terribly dull, and no one wants to do that. And not everyone likes to take tests at 9:30 in the morning or even get here on time.
What's the style of the actual lecture? Is it like all lectures questions?
So it'll be some short answer, multiple choice, true, false, fill in the blank style questions, and then you generally do like 3 long answer questions. Like here's a relatively short. Ideally, you could take it and finish that in 10 minutes or so. If it took you all 20, then you got a little bit of extra time. So I'll give you a sample one on the 12th you can look at. We'll go over it on the 17th, and then it'll be very similar here. I did not post quizzes yet. Crap. I was supposed to be doing quizzes every chapter, and I forgot here. Okay. I can put a couple quizzes in here. They're quick, just so you see what the style of questions are like here. We won't do one per chapter here. That'll be too much, but I'll throw a couple in there for you, so that way you can see what the quiz questions look like. You get familiar with those. There'll be half quiz questions and then those 3 long answer questions. You'd write something that does this, write a class that does this, but small, right? Not large like a project here. Yeah, so I'll show you what that looks like. And then after that, we come back and we start looking at some specific libraries. There's lots of really fun ones I want to show you here. Hopefully you got some information. I don't know if you've had a chance to reach out to any companies yet here. So I posted a link to just a little Google Doc here. You can start adding which company you contacted. And then if they came back with any answers, add what libraries they're using here. So we can get that nice list here. Then for our final project, you'll be doing something with one of these popular libraries here. It's going to be rather open-ended here. So if you've always wanted to dig into PyTorch and build your own neural network, go for it. That sounds like fun, if you can talk your team into it, right? So we'll figure that out. So I did make in groups. Where is that? I think in people, there's a group section. If I click that, all your names show, and you probably don't want that on YouTube, though. But go to people and groups, and you can self-assign yourself to groups. So we've got, I think, 60 people. We should be able to get 20 groups of 3 people for the final project. So start getting to know each other, right, if you haven't already. And you can assign now if you want. Here, start thinking about what things you want to work on. That's great. You've got to pitch the idea to me, and then I'll give you a quick yes or no. Right? This doesn't need to be like this huge, hey, here's a super complex project. But like, hey, we want to do something with these libraries. Say, okay, that sounds cool. And then figure out what you want to do and let me know. Okay, and that sounds cool or not, right? There's a couple basic tutorials, and then there's some more interesting things you can do. You don't have to go crazy with it, but something more than a little hello world kind of example here is what we're looking at. Just having a chance to do something with libraries that people say are popular. You can just Google popular libraries, but I think it's cool to actually see what companies are using as well. If anyone's getting back to you, has anyone had any luck? A couple of people asked out already, but okay, nothing yet. Ideally, we get a couple responses. We'll see. We'll see how well it goes. With 60 people asking, should get a couple hits. Yeah.
If we just company what libraries, I said to you or just copy.
How do you know? No, like, yeah, sure. No, that's fine. Yeah.
My project is still running.
So the grader's still working on it. I got to meet with them this afternoon and see. Yeah, it looks like we've got a couple more for two that need to go.
Like, let me check. I think every weekend it might expire, so I have to send it again.
Okay. All right, I'll chat with them about the invite. Thank you. Yeah, they do expire after a week. So if you invite me, usually if you just use the same repository, you don't have to keep doing that. That makes life a whole lot easier, right? Just make a new folder in that repository. Now you don't have to deal with more invites. Yeah, I'll chat with them. Looks like they're through most of 0 and 1. They should be moving on to 2 this week here. All right, awesome. Should we move on to more fun stuff? Nope, that's not 40. That's not the right URL. This one here. So this is going to be a little bit fun because you may or may not have had a database class before. And there's a lot of things we need to know about databases for them to make sense for us to use programmatically. But literally everything in the world is stored somewhere in a database. So being able to work with a database in code is going to be super helpful. Well worth your time here. So the quick, easy one we're going to use is SQLite. This is a smaller, condensed, small version here. It's not an enterprise database here, but all the same concepts apply, right? Just the enterprise level databases do more things. They have more bells and whistles. They're a lot fancier, these sorts of things. But SQLite works for us. It's just a nice, small, little personal database, essentially, that we can use in our application, right? So with a database, if you're all familiar with Excel here, does anybody use it? You guys use Excel anymore? Okay, good. Or Google Sheets. We're doing that here, right? You get columns and you get rows, right? That's sort of the concept here. So the idea with this is our particular columns are going to be named something here. So, hey, if we wanted to have a list of or a sheet of products here, so maybe we'll call this one, hey, this is products. Right? So things about product that we know about, they probably have some sort of unique identifier here. They probably have a name. They probably have a price. We probably have like a quantity on hand. This is really small, so let me zoom it in here. Right? Things about this product that we're selling, whatever it happens to be here. Right? When it comes to ID numbers, I'm a big fan of auto-generating these things. There's a couple different schools of thought here. Whatever's fine. I think auto-generation is nice and easy. That's okay. We can do it any way we want here. So we might say, hey, this is product number 1, and then the next one will be product number 2 and 3 and 4 and on and on. Every new product just gets the next number here. Works out relatively well. If you run into more than 2 billion products, you probably have a problem because at some point, the way that we're storing this, and that gets more into database theory, we run out of room for an integer. I think back your integer is like 2.1 something billion here. You might run out of space. For what we're doing in our example, we're not going to get more than 2 billion of something here. But in the real world, tables get really big. So you've got other types of identifiers you can use if you want to. It's not too big of a deal. So we'll have apples here. Apples are what, like 99 cents each, and we've got, I don't know, like 50 of them on hand here. And then maybe we have bananas, and those are 29 cents each, and we've got 100 bananas on hand. And then maybe we have some carrots. I don't know, carrots are pretty cheap, like 15 cents a carrot here, and maybe we've got 200 of those on hand. And then maybe we've got some donuts. Donuts are what, $1.50 each or something, and maybe we only have a dozen of those, right? But the idea is each column says this is the attribute here, and it fixes the type. So all prices will be a given type in the database. Like, hey, these are floating point numbers here, doubles, whatever you want to call them here. So anything in the price column will be that given type. Anything in the quantity on hand, probably an integer here, right? Hey, these are whole numbers. You probably don't have half a banana for sale, right? Whatever we're setting here. Name looks like some sort of string. Easy enough for us. And then each row then is an instance, right? Or it has each one of these attributes here, right? Makes up one of those type of objects. So working with databases here, where we've got columns that have attributes here, and each row is an instance, works very well with how we like to deal with things with object-oriented programming. Hey, I probably have a product class, and it's got a bunch of attributes, and I can make instances of that class. It maps relatively well for us here. Now, what gets to be tricky here is when we say, okay, so I've got product then, and I have, say, an order here. So I wanted to be able to order these things here. So I'm going to have an order ID. I'm going to have, I don't know, like customer ID probably in here somewhere so you know which customer I am. And then what do I want? Like, here's a product ID that I want here, right? And then I probably have like an order total. But if this is all I have, how do I buy more than one product? Right? So I say like products IDs or product IDs, like, and I say, hey, I want 1, 2, 3, 4, but like how many of each do I want now? Here, right? It gets to be really messy. So when we have tables that need other information from other tables here, we can do that. So like customer ID is really easy. We're going to make a customer table here, and we'll say, hey, customer, and this is what ID, name, I don't know, address, because we probably ship stuff to them. I don't know, whatever we want to have in customer, right? So, hey, customer number 1 is Eric at somewhere in Dearborn. I forget the address here of the college. It's on the website, right? And customer number 2, we'll say Jeb back in Wixom if he wants to ship stuff to Wixom. Sure, right? So when we place an order and you say, hey, I want the customer ID, I don't need to repeat all of the customer's information here. I just say, hey, this is for customer number 1, and it relates to an entry in the customer table. So our technical terms for these things, the identifiers here are called primary keys here, and identifiers in other tables that relate to primary keys are called foreign keys. It's a key in another table. So one of the things databases are good at is we'll call this thing referential integrity. It's a fun term here. It means that if you put a number here, it references something and it exists. It has integrity in its reference. You can't put customer number 7 here if there is no customer number 7. Your database will puke on you. That's one of its jobs here, right? With database management systems, they're good at doing that sort of thing here. And the idea is to make sure we don't get bad data. So yes, here's an existing customer. Okay. Now, I don't want to just have a list of IDs here because that gets to be really messy. So what we need to do here is we would look at how tables relate to other tables, right? So we talk about this in terms of relationships. So one customer can have many orders. So we say this is a one-to-many relationship. One customer has many orders, one or more orders, really even 0 or more orders, because you can be a customer before you place an order. Hey, I've registered with your website here, but I haven't bought anything yet. And then I can go look up customers that haven't bought things yet and send them promos and whatever, right? What other business things you want to do here, right? And then one product can be ordered multiple times. So one product to many orders, right? So that's a one-to-many relationship, right? But then order, we want to have multiple products, right? So one order wants to have multiple products. So if I say one order has multiple products and one product can have multiple orders, that's a many-to-many relationship, and that makes our database sad if we don't have a way to handle that. Because, hey, I've got a list of IDs here, or maybe in product, I might have a list of order IDs, and that just gets really messy. You can imagine trying to track that down is going to be really hard. So what we do then is we add a joining table. We put something in the middle here. And we say, okay, I can relate both of those concepts here. So this is going to be our order item. So this is an order item ID. This is just our ID here. And then we're going to have an order ID, and we're going to have a product ID and a quantity. So in this table, we say, okay, we just auto-generate, right? 1, 2, 3, whatever we get here. Hey, for order number 1, it has product number 1, it has 2 of them. Order number 1 has product number 2, it has 5 of them. Order number 1 has product number 3, it has 1 of them. So we get this joining table here. So now the order item relates one order, right, to one product. but you can have multiple entries here. So one product is in multiple order items, many order items, but each order item only relates to one order. And one order can have multiple order items here, but each order item only has one order. So we solve that many-to-many relationship. We can implement it with this joining table here. We say, okay, one product has many order items, and one order has many order items. And that way we don't have a many-to-many relationship because that makes our databases sad. Right? This is the relational databases, the most popular kind here. Not getting into the fun NoSQL stuff. That's probably more than we want to get into today. Right. And then we can go, hey, the next order, the next order, the next order. So we can find all this information. So we're taking the information out of, hey, a list here. So we don't even need product ID here, right? We just need to know, hey, well, who's the customer and what is their total, maybe, and whether or not it's been paid or those sorts of things, right? Paid status or something like that, maybe, and whatever other things we want to track here, right? We can do those sorts of things. Now, having the total here is helpful because if at your store you want to say, hey, we want to run a sale on bananas and make my bananas, now they're going to sell them for 19 cents a banana, bless you, here. You don't want the total to change, right, underneath their order. Right? Once you've bought it here, that's your order, that's your price, it's fixed here. So we need to store that point in time total separately from the product table, right? We could go compute it and say, okay, hey, this order had product one, we had two of them here. Okay, well, product number one cost 99 cents each, right? You can go and compute those values, but because this one changes here, we need to keep that computed total, right? So we can have that information here. So rows with tables and columns, right? This is the relation and the attribute, if you like your technical terms for it, which is fun. So a quick, easy way to view SQLite databases is the SQLite browser, which is really nice. It just lets you view them easily. There's lots of different ways of doing these things here. The nicer version of PyCharm, if I remember, has a way to open them up directly. But we don't have the nicer one, right? Because that's one of their premium features they put behind their paywall. So just use the SQLite browser. It's easy enough here. We're not going to do a project on this here, but it's fun to play with and tinker with here. So we've got SQLite. Should have that already installed. I don't know what version I had here though, so that's fine. Let's go this one. Okay. Yeah, okay, let me unzip that. Zip. Okay, that's going to be nice and slow, sure. And then we'll go back. Wasn't that it? I thought that had the setup in there, didn't it?
No.
Off of SQLite.
Yeah.
I go to downloads.
When you scroll down, it has to file bashes.
That's for Android, Linux, Mac OS. Ah, thank you. Yeah. 64-bit version. Ooh, SQL Analyzer. That one has all the tools in it here. That's fun. All right, so we don't need all the fancy ones here. SQL tools. Okay, thank you.
Sure.
No, I'm too lazy for that. All right. Oh, smart screen. Yeah, we probably trust them, right? All right, cool. So we've got our database here. We're good. Got it downloaded. We'll use the SQL browser now. SQLite browser. Look at that pretty tool here. This one's fun. Let's download. A zip with no installer. There we go. That's fun. How big was this one?
Yeah.
Well, it wasn't too bad. All right. Like zip. Extract this one here. Eventually, though, we can build our own tables, which is lots of fun. So using a tool to build your databases is going to be a little bit more friendly than building them in code, but you can build them in code. Right? Depending on what we're doing here, we can build them dynamically, but kind of going through the concepts gets to be a little bit awkward first time here. So it's nice to have a little visual tool rather than doing it all by hand here. So here's a little SQLite browser. This one doesn't zoom very well, I'm sorry. But I can say, hey, I want a new database. So let's go put this one in my GitHub folder for 298 in the week 8 databases, and we'll call this one test. Okay, now, hey, do you want to add a table? Right. The database by itself without any tables is not very interesting, right? So let's add a table. So let's add a product table here. And it's showing you this is the SQL code it's going to run. Sorry. Oh, it does zoom a little bit here. There we go. The rest of the menu doesn't here. So if you've taken the database class and are familiar with SQL, go nuts. If you haven't, that's okay. Not the end of the world here. So it's showing us, hey, we're going to do this. And then what fields or what columns do we have here? Right. So we're going to have an ID. Now, SQLite has a limited list of values here. Enterprise relational database management systems have a very big list of these things here. But for our purposes, integers, text, blobs, we're not going to worry too much about. You can store binary data in blobs, real, and number. Right? So integer should be fine here. And then it says, okay, which of these things do we want here? These are really messy. Don't worry too much about them, but PK for primary key, AI for auto increment. This is I want this ID number to generate for me. Every time I add a product, database, you tell me what the next number is, so I don't have to track it. Yeah.
Don't you need the not null or those?
So because it's the primary key, it's not going to be nullable anyway. Yeah. So yeah, not null and unique here. I don't know why they don't give you better names here. Like it's not hard to add those things in here, but that's okay. Right, so we got it. This says it's the main identifier. So primary key this is a unique identifier for this row. And every row gets a unique primary key here. We'll use that in other fields as the foreign key. Say, hey, here's the product ID. Right? It relates here. Cool. So we got that. And then you can say, yeah, you can even go into these foreign keys and specify things like that. You can add all sorts of fun stuff here as we go. So we got name or ID, we got name. This one is going to be text here. And then we were going to have what? Price. I think that one is that numeric? Sure. And then we're going to have what? Quantity on hand. And that's probably an integer value as well. Right. So there is our product table here.
This is American.
Pretty sure. It's been a minute. Sounds right.
I thought there was a somewhat to like it's not.
Not in SQLite. Field types. Let's just Google it here. What do we get? Data types in SQLite. Reals are floating point values here. What does numerics give me? Numeric. Converted to integer or real here if it fits. Sure. So I guess that's more flexible. I don't know. Yeah. All right. So we got that table. And then we're going to make another table then. So we're going to have our customer table. Customer had an ID. That's our primary key. It auto increments. We had a name. And that's probably fine. We don't need to track all sorts of other information here. It's just for the sake of the exercise here. So we've got customer, right? Aren't your names integers? Let's see. Can we change that? Let's add it. Modify table. Save. Yep. Make that text. Thank you. Good catch. That'd have been fun. Okay. Name an integer. And then we're going to add order here. So an order has an ID. It's an integer. It is a primary key. It auto increments. And then order has a customer ID. Now, some people have different naming conventions when it comes to their tables. Just smile and nod at your company. Follow whatever convention they have. I'm very partial to this one. I don't like putting order ID in the field name in the order table. I think that's repetitious. And the previous company I worked for also thought that was repetitious, and we didn't bother here. But sure, right? However you want to do it here. So you got customer ID, and then we're going to have a total, right? Total for total price, total cost, I don't know, or just total. That probably makes sense here. And again, we'll go with numeric. It should be fine here. And then to foreign keys, we're going to add this as a foreign key. So we're going to say, hey, my customer ID table then references the customer table ID field. Wow, did I screw that one up? I did. Move that one. Customer ID. Oh, I have to move it over to selected. There we go. So the customer ID field references the customer table ID field. This is going to enforce that referential integrity, right? So I can't put a customer ID here that doesn't exist in the other table. Say, okay. Oh, error creating. Number of columns doesn't match. I have to give it a name, really? ID. Now is that happy? Okay, so it names the constraint. Is that? No, the field list is wrong. Oops. What happened there? Somehow there were multiple columns there. That looks much better now. Okay. Say okay. All right, so now we've got order, right? It's got its ID, the customer ID. So who purchased this one here? And what was the total? And then the last one here was going to be order item. Item. So order item had an ID. We're going to just auto increment it here for ID. And then it had a order ID, which is an integer. There'll be a foreign key. And then it had a product ID, which is a foreign key, which is an integer. And then we also had quantity. Right? How many of those did you buy as an integer? So this one's nice. Bunch of integers. And we can add 2 foreign keys here. So our order ID then maps to the order table ID field. Order ID. I don't know if names are required here or not. And then we'll add another one then for customer ID or product ID. So product ID references the product table ID field. References. There it goes. Okay, so now it looks like it populated all of it here. And say okay. Now we got our tables. Okay, so now I can start putting data in the tables if I want. So I can go to browse data here and pick which table I want. Again, this is the quick, easy way of kind of exploring, playing with it. We're going to do it programmatically, but doing it the first time, playing with some of the data, exploring it this way is going to be a little easier to start. Okay, so hey, let's go add a customer right here. Right, so we want to add my row. Oh my goodness, browsing. Where is my ad? It's been too long since I've done this here. Goodness. That structure. Can I just, isn't there like a view in here? Really thought there was an insert. That's okay. We'll find it. No, nothing. All right, we can do it the hard way then. That's fine. All right, so in the SQL, we can insert into customer, and you tell it what fields you want here. So I'm going to insert. I don't need to insert an ID because that's going to auto generate. So I just need name. Right. So in my customer table here, right, I've got ID and name. ID will auto generate for me. So all I have to do is add a name here. So I'm going to say values, Eric. So all of that now to go and insert a value. Finished without errors. Look at that. One row was affected. Yay. And now if I go browse my data, I have customer. This one does not zoom for me, but customer error here. Great. So we can see that one. And we can add another one. We'll add Jeb in here, or Jeb is always in my programs. And I can browse. Now we have 2 customers, right? Yep, Eric and Jeb. Awesome. And then we'll go to our product table here. So we need a name, price, quantity on hand. So insert into product. You want name, price, quantity on hand. I misspelled quantity, guys. That's fun. Right, and we just comma separate. So we had apples. We said what was 99 cents an apple or something like that. We had 20 apples on hand. I think we can give it more than one row at a time too. Bananas, 29 cents a banana. I don't know, 30 bananas on hand. Carrots, 15 cents. So we had, I don't know, 100 carrots. Let's try that. Nope. Oh, jeez.
You misspelled
I misspelled everything. I misspelled everything. Is that going to run for me now? Oh, insert to product. Why does it not like my insert? Can I just run it once? Okay, sure. Apples, bananas. It's not my favorite browser here. 29 cents. And we got 10 bananas on hand and carrots. Carrots. 15 cents. So maybe we'll have 100 carrots. And we go browse. Now we go to products and we got some products. Awesome. Then we need to go and add an order, right? So we are going to insert into order. Order had a couple other fields. Order had what? Customer ID, right? And an order total. A total. So for customer number 1, right? Maybe what do we want to say? If I bought 10 carrots and some bananas, I can't math right now. It doesn't have to make a lot of sense here. We'll say it's for $2 here, right? Insert into order. Doesn't like, is it order? No, order? Customer ID and total. Insert in order.
Is it order a keyword?
Yeah. So if I quote it here, that's fun. How's it going to work? Okay. Yeah, order is a reserved word in SQL. That's my bad. So you can quote your table here. All right, and then we can see an order. Now we've got an order. Order number 1, customer ID 1, totals for 2. Now we'll go to order item, do order ID, product ID, and quantity. So order item. We have an order ID, a product ID, and we have a quantity. Okay, so order ID. Now, if we change it here and say, hey, I want order number 2, here's some product, here's some quantity here. Now we're going to get this foreign key constraint failed. This is what you want to have happen. So it's ensuring referential integrity. Saying you can't put this in here because you don't have a value here for this particular one here. It's not giving us a great error, which kind of sucks. It's not the best. But one of these things was bad because of a foreign key. So if I fix that to order number 1, product number 2, and I want 2 of them here, that one should insert. And I can say order ID 1, product number 3, I want 2 of those. We'll do 3 of those for fun. Right? And now we can see, hey, I've got some order items for that particular order. Lots of fun stuff here. So we can get it back out. Right? So all that work so that we can have some data to play with, to look at, and then we can go and insert our own in Python here. It's going to be a lot of fun. Oh man. Okay. Let's go back to where we are. There we go. Database. So importing SQLite 3 gets us started here in Python code. And I think we've got that one, right? Yeah, it doesn't even need to go download it. Nice. Yeah, it's just unused. Sweet. Built in.
Does Python already have that?
Yeah, it's part of the standard library.
We need to install it ourselves first.
Oh, it should be there. So when you connect to it here, you're going to say, hey, here's my name of my database, .SQLite here, because we created this file. So we go save my database. Yeah, good. It's all saved. I want to write all my changes here. So I'm all set. I've made all my changes here. It's test.db here, right? So I should be able to open test.db. And I don't actually want to drop any tables here. That's fine. Test.db. Hate how he uses short words here. Okay, so our cursors we're going to use to do this connection, right? We hold on to our connection to our database here as we go. So he shows you, you can say, hey, if the table exists, drop it, and then you can create the table. Here's your code for creating a table. I like doing the exploring bit here. So here's the name of the field, and here's the type that it's going to be, right? Title is a text value, plays as an integer value for this table here. So we can go and create that database here. We don't need that one. So you can do your own inserts here. Now, this substitution method here with the question marks is the correct way to do this. It's going to feel a little bit obnoxious, but it prevents a couple issues from happening here. So, is it OWASP? top 10 here. Oh, that's not. Is that their actual website? No, Salt Security. No thanks. This one, OWASP.org. This is some sort of security group. I forget who they are. They track the top 10 most common security vulnerabilities in software. And we've had injection. SQL injections have been on here for a long time. Here, yes, injection attacks here. So if you can take someone's code and stick it into a SQL command, and then you run that command without doing any sort of validation, any sort of sanitizing, any sort of checking on it, bad things can happen. There's a whole comic here, SKC, which is fun. It doesn't make any sense. That's okay. But this is one of my favorite comics here. So imagine the student's name was Robert apostrophe parentheses semicolon drop table student semicolon yada yada yada. If you just stick that into your database and hit run on it, the drop table command deletes a table. So if you don't do any sanitizing and they've now ended the string here because you're just string concatenating before you run SQL, bad stuff happens. So with SQL, the library here, if you use the substitution values, it checks for us and sanitizes for us. Does good things here. So always use the substitutions to protect against that. It's so easy nowadays. I don't know why people don't. So we'll pick it back up on Thursday. We'll play some more databases. We'll finish out building our application here. We'll have some fun. It's good stuff. You're not going to have to do it. But super interesting because everything literally in the world is in a database somewhere. So, all right. Thanks, folks. See you Thursday.